I'd like to talk to you today a little bit about a project that I've been working on for over 18 months now called Critical Maths. I think it's fair to say that Critical Maths started with Professor Sir Timothy Gower's weblog, particularly in which he started to look at the sort of qualification or curriculum that might be interesting to non-A-level mathematicians, and particularly about the content of that course and the way in which the course was actually taught. And there are several comments in there about Professor Gower's ideas. As Stella said earlier, MEI were lucky enough to receive some funding from the DFE to try and develop these ideas further. We've got an advisory group of people from all sorts of areas, people from the University of Nottingham, from the Shell Centre, people from Enrich, and a wide variety and diversity of opinion on there. And working with that group, we were able to pull together a draft curriculum, which we sent out to all of the awarding bodies, but also some teaching resources, and really a set of core values that underpin critical maths. Some of those Stella's already mentioned. I'd like to share some of the thinking that went into the development of those core values and the curriculum, really so that you can understand where we are now and how we got there and the thinking that went into that. One of the points that Professor Gower's raised in his blog was that because we need to appeal to a different group of learners, really what we need is something different, learning in a different form, because otherwise, why not simply do an A-level or an existing qualification? So we search for something different, but different how? I want to start just by looking at this section from the Smith report. These are some of the reasons why it says in the Smith report that students choose not to study mathematics after GCSE. The influence of the teacher, and not just poor teaching, but I think the diet that they've actually received at Key Stage 4 and GCSE may well make them think, that's enough, I don't want to go any further. And Tim Gowers mentions that in his blog as well. Oops. The perceived difficulty of mathematics for things like league tables and points, but also for students thinking about UCAS points. Now, I think it's fair to say that since 2004, the landscape has changed, and maths is now, I believe, the most popular A-level choice this year. And if not, it was certainly in the top two. But there are a couple of other points up there that worry me a little bit and got me thinking towards the development of critical maths. The third point, that students find maths boring and irrelevant and lacking stimulation. And we've certainly tried to do things about that in critical maths. And finally, the bottom point there, a lack of awareness of where it links into other careers and how maths can actually be useful. So we thought a lot, particularly about those two bullet points at the bottom there. It's not the only document. This is another document that you may or may not have seen. You've had a read through. The initial title, I think, is I would rather die than do A-level maths. And there are all sorts of comments in there about students' attitude towards mathematics and what they think about going on and studying A-level mathematics. There are other documents, there are loads of them, and you can go back historically, but all of those, I think, shout out that we need something that's a little bit different from what's in existence at the moment. And with critical maths, one of the ways in which we've tried to make things different is the teaching approach. We've tried to work with something called guided discussion, and this was suggested as one of the ways that we might use and make it more discussion-based to give a different learning experience. And whilst I was thinking about and trying to explore how we might introduce this guided discussion, I found an article called Beyond Show and Tell. It has been presented at some of the other conferences that I've been to, and I do know there are lots of people interested in this, by Professor Takahashi. The article describes an approach that's commonly used in Japanese schools, and a process where they discuss things. I think the technical term for it is neriage, and I think it's got great potential, and I've used it to develop some of the teaching resources for critical maths. Before students ever start to learn anything about mechanical calculation, they're given a problem to think about. In this case, on this problem, the students are asked to decide which of those three rooms is the most crowded. I don't know if you can see right at the very, very bottom, but it also says, how could you figure out how to measure crowdedness? How could you figure out something that could actually measure crowdedness? Whilst the students are working on this problem, the teacher, safe in the knowledge that they know roughly what they expect the students to come up with, because they've either taught the lesson before or it's in the teaching notes, can wander around the classroom having a look at what the students are actually doing. They can select items of work, not all the work, but they can select certain key items of work for discussion later, because they've got in their head an idea of the way they want the discussion to go and the points that they want to bring out. And then what generally happens is there's a discussion and the students discuss the work. There are occasional prompts and questions from the teacher to try and keep things on track, because they know roughly where they want to go. But the students discuss the work and they discuss their ideas, and slowly from that a collective understanding of that particular situation, and not just that, the mathematics that underpins that situation starts to come together, and they talk about the most effective methods and how things might work and how things might be done differently and which method might work better in certain situations. And only then do they start to look at the actual mathematics that underpins it and an algorithm. And then what they tend to do is they will move on to other contexts which also share this mathematical structure. And so what we've tried to do in critical maths is we've tried to take this idea of several contexts that share a particular mathematical structure in a lot of the resources. And I'll show you a few of those later. In the teacher's notes that accompany critical maths, what I've tried to do is I've tried to put in there what we would expect students to do. So just like the teacher in the classroom who can have a wander around and get roughly an idea of what's going to come out of the classroom through trialling these resources with students in several different schools on several different occasions, we now know roughly what to expect and how the discussion can go. So those are in there in the teaching notes. There are also suggested questions and prompts that you might use. And I'll show you some of the way in which those have evolved as we've been developing the resources as well. To try and make things interesting and to try and get that initial hook, what we do is we try to start every critical maths lesson with a question. And it starts with a question that's fairly easy to get into, and I'll explain a little bit more about that later as well. But the question tends to link to something which might be something they may come across in their future personal life. It might be something that they may come across in their future professional life. Or it might be about a social, an environmental or a world issue, something that's happening at the moment. Or it may just be something that they're curious about. This tries to help to get around the statement in there from Smith about maths being boring and irrelevant and insufficiently stimulating. Here's a question from the early critical math resources. This one's about medical screening. I'll give you a moment just to have a look at it. The initial response to this question, students are asked, how worried should someone be if they get a positive result from that medical screening test? Overwhelmingly, the students' opinion are either extremely worried or very worried. It's very, very rare to get any of the bottom two there, and quite often it's because students have misunderstood and misinterpreted the question when they've actually read through. And when they pushed a little bit deeper to think about why that is, the general comment coming back from students is that the test's 98% accurate, followed by the worries about the potentially fatal medical condition. So we then push them to think a little bit further. What about the group of people that get a positive test result? Do you think almost all of them will have the medical condition? Do you think quite a lot? Do you think there'll be more in that group that have or haven't got the medical condition? And how might we find out and put some numbers on those figures so we can actually think a little bit more about it? This is where the maths starts to become involved. To be able to make a decision and to be able to think that little bit more about that situation, they need some mathematics. This generally leads them towards a structure like this, through the discussion and thinking about them working on the problem. Something like that, we could start with numbers and eventually we get something like that, where they put the 100,000 people in that are tested, They work out the number of people they expect to have the condition and not have the medical condition, and then from that, with the test results, the 98 out of 100 people getting the correct result, they get that situation there, a frequency tree. And then they can actually look at and think about the situation that they were asked initially. If we put all the people together that got a positive test result, are there more people that have actually got the medical condition or not? And it's surprising that they find there 2,000 people or almost 2,000 people in the group of 2,100 that don't have that medical condition. When we showed this to some teachers for the first time at school, they were absolutely wowed by that little piece of maths there and the counterintuitive thinking from just that one situation. But critical maths doesn't stop there, because it's about using numbers and it's about using maths in those situations to take it one stage further and explore the context. So we ask questions like, looking at those 4 boxes, what areas would you worry about? The 2 people there that have tested negative even though they've got the medical condition. What might you do to make sure that situation is made better? And they generally come up with the fact that they repeat test after certain periods. There might be people in the early stages who've not been picked up by the test. And also, what about the group of people there that have actually tested positive for that medical condition, that haven't got it? They go on and they'll get some further testing to rule that out, and the worry and thinking about the way in which they might structure advice to that group of people. So it's not just about the numbers, it's about thinking further in the context and explaining. And in some of the assessment trials that we did, one of the bits that students tend to miss out was thinking a little bit more deeply about the context. Then, just to the Japanese approach, we take that context and use it somewhere else. This is the same style of maths, but this is looking at a completely different scenario. This is looking at a spam filter in a business with 3 separate settings on it. A sensitive setting which filters out lots of things but could filter out your good emails, working their way through to a weaker setting which doesn't filter as much out. And again, the students can produce the frequency tree diagram. They can start to look at the consequences of emails getting through. We had quite a good debate about this in class, where people were saying that, well, they'd opt for the most sensitive setting, because even if you've got a good IT policy in your particular workplace, not everybody might follow that, and you might put a lot of temptation there in front of your workers. And there were other people that had the opinion, no, you're going to lose a lot of business email coming through there. Not everybody's going to check the junk email folder. And there was a diversity of opinion, but they were able to back up that argument by figures because they understood the structure of that particular question. One of the other things about critical math resources that I like is that if you didn't want to start with a medical testing example, you could just as easily start with that example and any of the other examples that are in there, so you can pick a context that you think may appeal to your students. You could look at something like DNA evidence if you've got a lot of law students in your particular class. If you've got IT students, you can look at that. And the medical information, again, people will come across that in their personal lives as well. So there's a flexibility within the resources to be able to explore whichever context you feel is most appropriate for your students at that particular time. All of those are fairly manufactured resources, but if you really want to get into the nitty and gritty and show that it does exist in real life, this is an actual document from the NHS about screening young children all the way through the process. And if you have a look up there, I don't know whether you can see the 4th one along the green, it's about Down syndrome testing. And you can start to have a pick through the information that's in there using that idea about the tree diagram. That most screening tests result in people getting through with a low level or a low risk. It says 95% there, I think it's 98 when you look a bit further into it. But there's that statement at the bottom there, overall 15% of babies with Down syndromes are not detected by the screening. And then there's further information in there about the people that come out in the high risk category. And this is the bit, again, that critical maths will help with, that ultimately if you have the test and you get a high risk, you have 2 options. You can either choose to go and have a more accurate diagnostic test, but that carries some risk with it, carries a risk of miscarriage. So you can decide, no, I'll go with what I've got. I'll hope that I'm one of the people that's had that positive test result and is not actually in that group. Or there's the very bottom statement there that says once you actually know that result, you can't turn the clock back, and maybe it's worth not having that test in the first place. Now, that's a debate that doctors have had, and there's press articles about it as well, if you wanted to make it even more realistic. And that is real-life maths that students may well come across in their future personal life or even professional life. One of the things while we've been testing these resources, quite a lot of the teachers that have been teaching the core math resources are non-mathematicians. And teachers of sociology, psychology, PE. And one of the things that I observed was they were much better at creating a discussion and starting a discussion and getting a discussion going than I was as a maths teacher. They had a real skill in being able to tease answers out of students. And I noticed that they tended to start by asking them their thoughts or feelings or opinions on a particular topic. So just like the one that we saw medical screening there, what would you think, or how do you think someone would feel? Because they feel comfortable about talking about their own thoughts and feelings and opinions, and it gets the discussion going really quickly. That can then be moved on to looking at data and analysing the situation and then getting into the maths behind the problem. Now, for the teachers of sociology and psychology, they were very good with the thoughts and feelings and opinions, and they needed more help with the data and structuring the actual maths behind it. As a mathematician, my temptation was to race through the thoughts and feelings and opinions and get straight to the data and the analysis, and that lost a lot of the context in there. So the critical maths resources are designed to get you to think about the context that little bit more, and we've started to put together some in-service training on that as well. This is the medical screening question, which we adapted later as part of the trialling. What we chose to do was to pop a little scale on there, and instead of asking them to pick between the four, to think about where they would place someone on that scale of how worried they should be. And that did actually create quite a lot more debate when they were working on it and thinking about where they ought to put the arrow. This is another resource that I've used with students. It looks at sample size, it looks at testing and confidence intervals, but in a very intuitive way. Basically, they have to design a multi-choice test for a teacher with 20 questions with answers true or false. But the teacher wants to be able to reward certain students, so to set a limit for giving the reward, but they don't want students to be able to get that reward by guessing the answers to it. And they need to think about what would be a suitable mark. Now, that was the starting point for the first lesson, and we got through, then we look at using bigger samples and how we get greater accuracy by using bigger samples. But then I suddenly thought, well, why don't I just ask them to sketch what they think the results from their class would actually be and mark it on a chart? Here are some of the answers that we got. I don't know if you see that one, but it's 10, the expected score, quite a lot, and then working the way down, but very few were higher than the expected score for that particular student. And then a more random scatter here, and here again. This was the interesting one that came up purely by chance. That one student came up with that symmetrical diagram there, and we were able to talk about why they thought that would be the right diagram of choice, and it just opened up that lesson much more. And that was something that they'd actually done in class. It wasn't me that had structured it, and it's great. A really good idea. So most of the critical math resources now start off by asking them for their thoughts and feelings and opinions. This is one, a Fermi estimate for someone maybe in business. Before businesses want to spend any money looking into and doing market research on things and wasting time, what they tend to do is they just tend to do a quick back of the envelope calculation to see whether it's worth investigating any further. So in this instance, this is a business opportunity. And students are asked, do you think that's a good business opportunity? Would it be worth pursuing the estate agent a little bit more to find out some details, or can you do some quick calculations and say, no, definitely not, you're not going to make a profit out of that? By far and away, some of the best materials come from the media or video clips, and it's really, really difficult to try and include those in resources because obviously they're copyrighted. I do put links to certain videos that I think are really good, and I do put links to news articles, but obviously they're only available for a certain period of time. This is one that was presented to us at a school that we went to fairly recently, and they've been trying to start their lessons off with a simple newspaper article and talking about that. And this is one where 2 students have suggested that if all the students in their university take their first wee of the day in the shower, that it would save 26 Olympic-sized swimming pools of water in terms of flushing. And the students were asked, could you really save that much water? And they had to think through and do some quick calculations just to check. The TED videos and all sorts of are really, really good to use, but again, they're copyrighted, so I've put them in as links in the teacher's notes, and you are able to use them. The feedback from the students has been almost entirely, overwhelmingly positive. They've enjoyed doing the mathematics in that way in class. And when I think that some of the groups that I worked with were general studies students who had almost been press-ganged into having an extra math lesson for 5 or 6 weeks so that I could try out some of the resources. By the end of that time, they did actually enjoy it and said that they'd enjoyed it and thought that if maths was like that, then they would probably be more inclined to take it and do. We're trying to gather some more evidence as well to support this, some hard evidence and data and facts. And it is only anecdotal evidence for students that I've actually been along and taught. We're trying to produce some case studies with Manchester University. And if anybody's interested in taking part on that, if they see me around at break, I'll give them a card. So I think to sum up, going back, critical maths is designed to give students a different learning experience. It starts by using an everyday question, which is linked to their future personal, professional life, social environmental issues, or just to arouse the curiosity. And it attempts to show how mathematics links into all sorts of careers and making decisions. So this bit I see as getting around a bit of the influence and the diet at Key Stage 4 from the Smith report. This chunk here, I hope, will make students see that maths is not boring or irrelevant, that it is actually relevant to them in a great number of situations, and that it does apply to lots of different career options, because they'll see it not only in critical maths but also in some of the other qualifications that we've talked about. Thank you.